range the other day, and figuring out like the intervals for those things. So today we're starting with, it says to graph the function. I'm not as worried about that part, but it says to tell whether or not it has a point of discontinuity at x equals 0. If there is a discontinuity, tell if it's removable or non-removable. So 22, h of x is equal to x cubed plus x divided by x. So if we wanted to graph this, so you don't have to like graph them by hand if they're talking about graphing them, you can just put them in your calculator. I'll put it up there with what it looks like in just a second. All right. So what does this graph end up looking like? Does that make sense?
Nothing in this math class makes sense.
It might be like imaginary species. Oh! It's just, it factors out, right?
It doesn't cross the x-axis. It looks like a U.
What was the question?
H of x equals.
Well, I know
x
that's the problem. What
Is there
question did she
discontinuity? Is there discontinuity?
Is there a discontinuity at x equals 0?
There is no x.
It's not touching 0.
So that means all real numbers, buddy. I mean, no real
No.
numbers.
If it was all real numbers, then it would have to be on the line.
I was like, what?
Yeah.
So let's look at something. Let's look at the value when x is equal to 0. What's going to happen in this equation if x is equal to 0?
H x equals 0.
It's undefined.
It's undefined, right? So that should be our dead giveaway that there's a discontinuity there. But does our graph being a parabola make sense?
No.
What is discontinuity?
Yes, right? Because I could factor out an x from the top and I would be left with x squared plus 1. So the graph itself makes sense, but I have to look and see if there's basically a denominator value that makes it undefined, which in this case would be 0. So the answer for this one would be yes, there's a discontinuity at x equals 0. And it is removable because basically it's just creating like a hole in our graph.
What is the definition of discontinuity? That word?
Discontinuity?
Yeah.
Not continuous.
What?
Continuity.
Like there's like a gap or a hole.
I didn't see any
It
gap
jumps. There's a vertical asymptote. I showed you that there's a gap when I selected this.
in there. I don't see a gap.
So if it touched the x-axis, then it wouldn't have a discontinuity?
Would it just have a continuity?
No, it has nothing to do with it touching or not touching the x-axis. It has to do with at an x value, is there a y value?
At any x value?
At the x value, well, in general, it would be at any x value. They're specifically asking us at x equals 0.
If x is 0, then y.
So when we find out where x, when.
Wait, how'd
Oh
you
my
do that?
gosh!
She zooms box.
You pressed x equal. How did you get the x equals 0 menu up?
Second trace value.
I zoomed standard and then now there's like a stop.
You can put a box, Charlotte. You see.
But it works this way too, right?
I don't see no discontinuity.
It's going to be hard to see on a graph like this. You just have to know rules. You can't divide by 0, right? Okay, that should be your giveaway that this has a discontinuity because you can't see it in the graph directly right now. What this graph would look like, if we could see it, it's not working, is that at, because it would be +1, we're going to have a hole here. And it's going to look like that, which is why it's removable, because we've just taken that value out of our graph.
A hole?
Yes, there's a hole, because that value doesn't exist.
Oh, so at the base of the parabola, there's just like an empty space?
Yes.
Oh.
There would be like a gap, but the way that it's normally drawn in your book is with a hole. If you look at problem like 28 in your book, you'll see there's a hole in that problem.
Oh, when you said hole, I thought you meant like whole number. That's why I was confused. In the actual,
I just
like,
drew a hole.
whole number. But that's like a filled-in hole. You know?
You showed me.
Okay, 24.
Pass the couch.
I'm just writing numbers.
G of x is equal to x over x minus 2. So all they're asking me right now is there a discontinuity at x equals 0?
No,
Why?
because it's 0 over -2.
Oh, okay.
Because at 0, there's no issues here. It's just equal to 0.
So when it okay
You knew
in
nothing.
in 22 when it's 0 it's not like x, it's like y equals 0, which is why there's nothing there at the y-axis.
When x equals 0, there is no y value because it would be
Okay.
0 over 0, which is
That makes
very
sense.
much a problem.
Okay.
But the denominator is 0, so that's another whole problem in and of itself.
So is there a vertical asymptote in 22 at the line x equals 0?
Which is why it's not really showing up on your calculator the way that I'm, like, it is, but it isn't. You just can't see it. I can't get it zoomed in quick enough. Now,
I just hit zoom standard and now I can see the gap in it.
Yeah, I can see
On
the
number
gap.
22.
it may have to do with the fact that you have a newer calculator than I do.
Colors might make it easier or something.
All right, so,
I can just tell.
no, it is continuous at x equals 0. However, in this one, there is a point of discontinuity
Oh,
at
2?
x equals 2.
Because we can't have a 0 on the bottom.
Can I see what
Is that the only thing that determines
I didn't
whether or
graph
not
this one.
it's-
Mine looks like this.
That should be what it looks like.
Oh,
So is x not being 0 in the denominator the only thing that can cause a discontinuity?
No, but for your problems, yes.
Okay, cool.
What we're doing in calculus, no, there's a bunch of different kinds. If you have like a piecewise function, or if you look at the pictures in like 25 through 28, which it's not what it's asking you to do, but you'll see there's like jump discontinuities where there's like a hole and then a filled value and there's like space in between and all of that. So that's obviously not continuous because it doesn't keep going.
So anytime that the bottom, the denominator is 0,
It's
there's a-
automatically going to be discontinuous at whatever the value is that makes it 0. And so at every vertical asymptote, it's discontinuous.
But it's removable if there's an option that doesn't make it 0? Okay.
Well, yeah, basically. For right now, yes.
Okay.
Usually removable will look something like this. You'll have another value that fills the hole. But if there's just a hole, essentially, a value that doesn't work, it's removable.
Okay, I see it.
That's more like in calculus, you'll have other things
I'm
filled.
supposed to know this because of my genes and stuff.
Yeah.
What?
Yeah.
Did you say you're supposed to know this because of your genes?
He's Asian. That's why.
Okay.
Like it makes sense.
It does not make sense, Zach.
What doesn't make sense?
The fact that we have to create an imaginary hole in a graph.
The hole is not
It's not
imaginary.
imaginary, it's
Right
just the
there.
bottom 0.
Yeah.
Yeah.
Because when
Only
you
when
divide
the
something by
line is
0,
zero.
you get nothing.
Do you remember when we were in algebra?
Then why
1?
don't we just write the answer as 0 and then call that the answer?
It's because it can't be
Because
the answer.
there are still answers, it's just not at 0.
Good one.
We just
We're not
know that
looking
the
for an
is
answer, we're
not
just looking for.
So does that mean there's two
Do you remember
functions?
in Algebra 1 when we talked about
What?
slope being 0?
This is one function.
There's one function, but there's a gap in
Yeah.
between
See,
the two.
see,
like,
we're tracking.
line things.
There's
Okay.
just a point where it's causing a problem.
I like this class now.
I lost this.
Yeah, you lost me as soon as
Okay.
Oh my.
Where do I want to pick up? Determine whether the function is bounded above, below, or on its domain. 36. Y equals 2 minus x squared. So what shape is that?
I don't know.
Parabola.
A parabola. If you have an x squared function, you should all be able to tell me it's a parabola. It's the only type of graph that can have squared.
Yeah, I'd get angry too.
Yeah, ma'am, I don't know.
You should be able to graph this without your calculator.
How?
We had a whole chapter on this in Algebra 2.
X equals 2, X equals -1.
No, it's an upside down parabola starting at 2.
Yes.
Oh, because it's reflected.
Yes.
Added two.
Stop stealing my glory.
This graph, okay, a normal parabola looks like this, correct?
Mhm.
Correct?
Mhm.
Yeah.
Yes.
Mhm.
An upside down parabola looks like this.
Yes.
Yes.
Okay, this one is shifted up 2 because it's not the stuff that's inside the x, so it's shifted up 2. So that means that my parabola is now right here.
Time to crack out the marker.
Okay, so this is my final graph. Is this bounded above or below or on its domain?
Above.
Above. It can't get any higher when your graph is facing upside. I can't do it. When your graph is upside down, it can't go any higher than that, correct?
Yes.
Okay, so this is bounded above.
Where it starts, it can't go past that point.
So is that the Bobo?
No,
Bounded above?
that's bigger
On bottom.
on bottom or bigger on top, or if they're both the same. That's
Bounded
horizontal
on
asymptotes, not boundedness.
So it's bounded. Okay.
There's
38. This is one that you probably don't know off the top of your head what it looks like. Y equals 2 raised to the negative x. If I don't know what it looks like and I need to decide if it's bounded, what do you think I should do?
Put in your calculator.
Yes. Graph it.
Alright.
Is your grandpa Chinese too?
Make sure you use the negative sign, not the minus sign.
No.
Negative sign or minus?
Might need a slide. Like
Wait, Charlotte.
yeah, like that.
Now, what do you know about exponential graphs?
It's. Oh, wait. I
They
remember
can
the word. I
grow or
remember the word.
decay.
Wait,
They can
what's
grow or decay. What's happening to this one?
0,
Decay.
Okay.
right?
They're not
Correct.
pushing
They
it
don't
out.
actually touch 0,
Whoa.
with the exception of if they're shifted down. This one is not being shifted anywhere. This one is just reflected, which is why it's a decay function. So it can't cross 0, so would this be bounded above or below?
Below.
Below.
Whoa. Hey, it looks like mine's touching.
It's going to look like that, but if you trace the function, you're going to see it gets closer and closer to 0, but never actually hits 0.
So if it's bounded below, that means that there's a number, like any number that's below the graph, then it's bounded below.
How do you be below a 2D graph?
You're like
Bounded.
capping your graph and saying, I can't go farther down than this.
Yeah, bounded is like bounded.
So there is no value.
It's like a hill or like a valley.
So then what
And
does
you
it
can't go any higher or lower. That means it's bounded, above or below.
So it would
respectively.
be above, right? Since it never goes past the x equals 0.
No, it's bounded below because it can't go lower than that.
Where's the
bounded
boundary?
point is the thing you can't cross.
Where's the boundary? The boundary is at the bottom, which
Oh,
means it's
boundary,
below.
I like it.
So there's no way to get a graph like this to equal y equals 0, is what it's saying.
Correct.
How?
Okay. Or
Because
y equals
what
negative.
value can you raise something to that it's equal to 0?
It goes up.
There's no value you can raise. You can get close, but you can't actually hit it.
It never goes
And same with, like,
below.
negative
What's
one.
the bottom?
Yes,
She just went off.
Okay, how about this one?
So much sense now.
This is so.
40.
This is the only thing I'm
Y equals x minus x cubed.
I got you in my calc.
Now, you should have a rough knowledge of what a cubic function looks like. However, this one's got other things happening to it, so I'd put it in your calculator. When I do it, I get something that looks like that.
Wow.
What does that mean? Is this bounded?
No. Yeah.
No, it goes on forever in both directions, so this one is not bounded. Not bounded above or below.
So can we go back to the continuity?
Can
I'm going to let you know, boundedness is way easier than continuity.
Yeah, that's what I'm trying to understand with continuity.
will every
Does the graph keep going or does it have a stopping point, basically? Is there somewhere that causes a problem
Oh, so is there a gap in
in the graph?
was continuity what we did on Friday?
Yes.
Okay.
Or no,
Wait.
we didn't. I don't think we started it on Friday.
I was
We
gonna
just
say,
did it
but
today.
I really didn't understand.
No, we didn't start it on Friday. I couldn't remember if we did or not. We just did it today only. Okay.
I remember when I first did a project at home, I thought I saw some letters.
Decided.
Chip, you're just gonna get more and more confused if you don't do the practice problem.
I'm gonna start playing games on my phone.
What we don't practice on.
All right. Max and mins. We're going to use our calculators for this part.
That sounds like something I could do.
Wait, I've never heard of max and min.
That's not possible because I taught it last year. Find all local max and min values of x and where they occur. So 42, g of x equals x cubed minus 4x plus 1. So a max and min occurs anytime a graph turns around, okay? Or, well, technically a parabola is turning around. So like the min of this over here, okay, of like a basic function, this graph would have a minimum. But the actual function that I graphed, so the one in red, would have a maximum, where it goes up and it turns around. It's where your max and min values occur. So put this graph in your calculator. Now, this is a cubic function, right?
Yes.
Okay. So whatever the type of function is, so if it's a cubic function, that means it at most has two either max or mins. Okay, it can have one less than whatever your highest power is. Now, it doesn't always have that many, but that's up to how many it can have. So this graph looks like this. So the beauty of your calculator is it can find your max and min values for you. So you're going to hit second trace. And if you look, there's one that says minimum, one that says maximum. So as long as you can read your graph, you can use these buttons. So the max value, you're going to arrow it over to the left bound, arrow it over to the right. This is like kind of how we found zeros, but this is a different function doing it for us now. So on the right, guess. So I have a max value at x equals negative 1.15.
That does not work.
My calculator crashed. What's the exponent?
How many over do we button left and right?
Just until you're on the left side of the max and the right side of the max.
Someone fix my calculator.
I thought we were finding
It
it.
crashed.
Oh, so like we're going.
But you should be able to visibly see where a max of this graph is.
So how can it be a max if you can have something above it?
Because it's a max where it turns around. Otherwise, it just goes out to infinity.
No,
This is called a local max and a local
Oh,
min.
local max. So it's okay.
So the minimum is the same thing, just on the other side.
Yes. So then you'll do second trace, find minimum. You'll go to the left side of your minimum. Then go to the right side of your minimum. Hit enter. So I have a minimum at x equals 1.15. So I have a max at negative 1.15 and I have a min at positive 1.15.
I really won't understand at all. Wait.
Can I check my phone? Is that my phone?
I don't know.
So
It's not mine.
when you set the minimum
I did that
to
yesterday
maximum,
too.
you
But I
gotta
don't
go
know if it was
all the
my
way
phone
to
or
the
not.
left. Like,
Just a little bit to the left of each of the hills or valleys, depending on which one you're dealing with.
My notifications are all the way down. Why
So
is it
second trace,
Yes, I did that.
okay, I'm gonna find the maximum. I'm looking for the left bound, so I need to arrow over until I'm slightly left of this very tall point.
Oh,
And
it's
then I'm gonna
good.
hit
It's
enter.
nice, not
Then it says right bound,
That's on me.
and so I need to go slightly right of the highest point, which is
Not a
right
runner.
here.
When you did the
Press
left
enter,
to the right.
and then it says
on
gas,
this time,
and
it's
then
for
I
the
press enter
exercise.
again.
You're supposed to do
And I hit next
the highest point.
You would just get shut up on
So you go to the left of the
I understand
and then you press
Okay.
enter. And you go right of the and then press enter, and then it can tell you what the highest is. That's the highest, yeah. And then you can do the same thing on the valleys, the lowest part.
Cash, can you explain to me?
Sing to me.
You go to the left of the
I got
valleys and-
1.66667. So like I don't know what else.
Then something's not right.
and something's not right.
Wait, so I do the first one,
You do it on the left.
Second
It's
count.
right there. You do it on the left of the
Minimum.
right
no,
of-
but like right on the left?
And you just do it on the left.
Anywhere on the left.
Anywhere on the left?
Alright,
Anywhere on the left.
Anywhere on the left.
She's making me more confused.
Anywhere on the right.
But when you do like your minimum, it's gotta be like when you do your minimum value, it's gotta at least be on this side of the maximum or it's gonna confuse it. Like you've gotta be somewhere in this range in here for your left of your
You
minimum.
can't just go all the
You
way.
can't be like over here for your left of your minimum.
Yeah.
And then for your right of your minimum, you're just somewhere over here. It doesn't matter where.
What?
Same thing for the max.
My maximum
I did
says
like it too.
negative .303.
I don't know
What?
why I'm not
Each.
sure. Negative 1.15.
Did you put it
I'm
in?
questioning if your graph is right.
I just need like watch.
Can I see your calculator?
Oh, well, you didn't hit guess yet. Now you have it.
What year did Magellan start his trip around?
It's gonna
the world?
ask you to guess after you do left and right. Make sure you click that or you're gonna get the wrong answer.
My bad.
It's asking me
I
Why
thought
is
that
that in
was
the
the
calculator?
what year did
Okay.
Magellan start his trip around the world.
McClellan's.
Yeah.
I'm gonna move on to the next thing. If you're still stuck on that, we can discuss it as you're doing your problems. 48. Even, odd, or neither.
6. Wait, either odd or even.
We're determining if a function is even, odd, or neither.
If it's, I know how to do this. I know my even and odd numbers.
Yes.
So that's not always a good gauge.
48. Okay, I'm ready.
All right. So this previous function, graphically, I can tell that it's odd because it starts down here and it goes up and it finishes in the opposite direction.
Yeah, never mind.
So if it's an odd function, they're going to finish opposite. If it's even, they're going to finish in the same direction. That's pretty much always going to be the case. There are a few exceptions for certain types of graphs, but I don't think you have any that are the weird kind. So what we do is we have a function. So 48 is g of x equals x cubed. I am going to replace x with negative x. If I get out the exact same thing I started with, signs and all, then it's even. If the sign has changed on everything, we used to say if it's negative. That was throwing people off because if a function starts negative, it may end positive. So now I say if the sign has changed, it's odd. If it's a weird mix of the two, it's neither.
Yeah.
What, like the sign for the max and the minimum?
We're not doing anything with max and min.
Oh, we're past it?
I'm on even, odd, or neither. So I'm going to take and plug in negative x. So g of negative x is equal to negative x cubed. Well, what is a negative number or a negative value raised to an odd power? It's negative. So this is negative x cubed. My original function was x cubed. The entire thing is negative. So that means that this is odd.
This equation is odd?
The graph is odd.
The graph is odd.
I think.
The function is odd.
But couldn't we tell that because it's,
Function, yeah.
because 3 is odd? Just throwing it up.
Just hold that thought for a minute.
Okay.
Just keep thinking that for right now.
I was thinking the same thing. You go.
50. Q of x
Fix it.
is equal to, I'm looking at the wrong problem.
Vivre.
Hold please. This is g of x. I was looking at 58, not 50. G of x is equal to 3 over 1 plus x squared. So I'm going to do the same thing. I'm going to plug in negative x. So g of negative x is equal to 3 over 1 plus negative x squared. Well, what's a negative raised to an even power?
Positive.
Positive, so this is 3 over 1 plus x squared, which is the exact same thing I started with. So this is even. Just keep holding. 52.
You're about to blow my mind.
F of x is equal to x cubed plus 0.04x squared plus 3. So by y'all's logic, what's this?
Odd, because 3 plus 2 equals 5.
Odd because it's the x squared, x cubed thing, which means it goes like the. And when you said that it was on that one, on the one before, you said that it was. You said it was odd.
All right, so let's mathematically find out what it is.
I think it's even.
I feel like she's telling us we're
So
wrong.
f of negative x is equal to negative x cubed plus 0.04 times negative x squared plus 3. So negative x cubed is what?
Negative x.
Negative x cubed. Then over here, plus 0.04 times negative x squared is what?
Positive
0.04x squared. And then plus 3. So what is it?
Why did the?
Neither.
Wait, why did
Neither.
Hey.
It's neither. Because this sign changed, this one did not.
Whoa. Why did the f of x become negative?
Because that's how we determine if it's even, odd, or neither.
Whoa.
So graphically, what does neither look like?
Please don't confuse me anymore.
It's okay, Mason. What's gonna confuse you?
This is gonna confuse me a lot.
Don't look.
The graph makes things make
Write
sense.
down the problem.
Why did you say Victor?
Do we
pull a
plug in the
force
original
majeure.
equation or we plug in the
Geometry.
edited one?
I like that.
The original.
It's
Okay.
black.
Oh.
Okay.
Did you hear my jokes?
It's not always going to, like,
That isn't.
It doesn't.
that's why
look
you have to,
either
it
odd.
doesn't always, that's why you can't just go off of it's going opposite directions, it has to be odd.
Yeah.
My joke was.
Sometimes it just depends on the graph.
Geometry.
Liar, bees, hands,
Geometry dash.
So something like 54 then, h of x is equal to 1 over x. What do you think about this one?
Even, because it's just a regular straight line.
Odd.
Come on.
Wait, 1 over x.
1 over x means that the
Because it's
slope,
not squared.
if it's y equals mx plus b,
That's not mx plus b.
Plug in
X
the
is in the
negative
denominator.
x.
I thought that was just 1
So
over
if we
1.
plug in negative x, I get 1 over negative x, which is the same as negative 1 over x. My whole function has become negative, meaning this has to be odd.
I'm taking a brain check.
I think I need
We're
a
going to
reading
take
break.
an academic break.
All right, our last stuff is with our horizontal and vertical asymptotes.
I'm not making
So horizontal and vertical asymptotes. How do we write horizontal and vertical asymptotes?
A minus 1.
As equations of lines. They are horizontal lines and vertical lines. So x equals something, y equals something. So 56. Q of x is equal to x minus 1 over x.
I think I'm getting too ill after this.
So vertical asymptotes always occur when the denominator is equal to 0. That's pretty much the only time we ever have a vertical asymptote. So, what makes the denominator 0 here? 0. So we write x equals 0.
Okay. Ooh.
Now, horizontal asymptotes. This is where you have Bobo, Bosco, Botno. If it's bigger on bottom, y equals 0. Bigger on top, no, there's not. There is not one. There is something called a slant asymptote. If they're both the same, we use the coefficient that's in front of them. So in this case, I'm only caring about the highest powered terms. I've got x over x. That means they're both the same. I use the coefficient. What coefficient's in front of these things?
1.
1. So y equals 1.
Would that one be Boston?
Huh?
Would that one be Boston?
Bosco.
Bosco.
Both the same. Use the coefficient.
You said the vertical only occurs when the
Denominator is 0.
So if the denominator was 16, then it wouldn't be a Virginia or a Virgin.
What?
Whatever the VA is.
What? Say one more time what you said.
If the denominator was 16, the VA wouldn't exist. It'd be undefined.
If the denominator was just like, if it was x minus 1 over 16, there would be no asymptote, vertical asymptote,
So
or
what would
horizontal
we
asymptote.
would we put like none? For the vertical?
Yeah, if there's not one, you just need to write none.
Do we need to explain why? Is it just implied?
No. 58, q of x is equal to 1.5 raised to the x. Now, this is the one problem in this entire section that is not a fraction.
Make it fraction.
But what do we know about exponential functions that have not been shifted?
They never touch the x-axis.
Shifted.
They never touch the y-axis. Well, the x, okay, yes. So there is a horizontal asymptote, what I was trying to say. Where would my horizontal asymptote be?
1.5.
No.
2.
0.
Y equals 0.
Why?
Vertical asymptote, there are none.
So
Because an exponential function does not cross the x-axis. So there has to be a horizontal asymptote at y equals 0. Unless it's shifted. That's the only time. This graph was not shifted.
So the asymptote is just like where it stops.
You okay, Anthony?
Yes, where it can't cross them.
So it's the
However,
same-
horizontal asymptotes can be crossed sometimes, but that's a problem for another day.
So it's the same thing as bounded or unbounded, just in both directions.
Sort of, yeah.
What?
Asymptotes help you to find where it's bounded in a lot of cases.
Okay.
60. This is probably the hardest section in this chapter, so just
I hope so.
unless you're not good at memorizing, then you might think the next
Oh
section's
my.
harder. 60. 4 over x squared plus 1. But unlike most math classes, it starts hard and gets easier.
Oh, okay.
So it's also your positive to the whole thing. All right. Vertical asymptotes. I need to find where the denominator is 0. So what you should do is take and set the denominator equal to 0. X squared plus 1 equals 0. X squared equals negative 1. What does that mean? I'm going to have an I. That means I don't have a vertical asymptote because x is equal to plus or minus I. Okay? So there are none. There's no value that's going to cause that to be 0. No real value that's going to cause it to be 0. Now, horizontal asymptote. I don't have an x on the top, meaning this has to be bigger on bottom, which is Bobo, so y equals
What was that?
0.
Hey, my tablet knew that. It told me that the horizontal asymptote was 0.
Wait, can you?
It got
please-
something right.
Are you flexing on us?
I just
Bobo,
wasn't
bigger
listening.
on bottom, y equals 0.
No, it's just
Oh,
like
okay.
wrong 95% of the time.
So,
it's okay,
if there's no vertical asymptote because there's an I, does that mean that number 58 there's an I in there too, or is it a different?
No, 58's totally different because it's not a fraction. Typically, we only have vertical asymptotes when a function is a fraction,
Some days in math, my head doesn't hurt like.
or if it's a trig function. We also have vertical asymptotes.
It's actually hurting right now.
There's trig this year too.
Lots of it.
You said-
All right, 62, but I'm doing a modified version of 62
What you just said.
because I want us to see something different. So h of x is equal to x squared minus 4 over 2x minus 4. So like I said, I basically just took the fraction they actually gave in the problem and I flipped it because I want us to see something with this problem. All right, so vertical asymptotes, I need to set the denominator equal to 0 and solve. So I've got 2x minus 4 equals 0. So 2x equals 4. So x equals 2. So I have a vertical asymptote at x equals 2.
Oh, that's how you figure out the vertical asymptote. Just at the bottom, the denominator to your. Yeah. Oh.
Now, horizontal asymptotes. I look at the highest powered x terms, top and bottom. So I've got an x squared over a 2x. So if it is bigger on top, which this one is, no, there's not. There are none.
Dr. Robotnik.
Now, normally when I'm listing out my horizontal asymptotes, to kind of give a reason, because there's no math to be shown like there is with a vertical asymptote, I will normally say like Bobo or Botno or something like that as my explanation, because that way that's kind of how you can get some partial credit on these problems in case for some reason you choose the wrong option.
You just write.
Well, you have to choose the right one to get some partial credit, but now,
Choose the
can
right
there be
one.
more than one vertical asymptote?
Yes.
Yes, there can. If I did this problem as it was originally intended, then it would have been 2x minus 4 over x squared minus 4. What would my vertical asymptotes have been in this case?
X plus or minus 2.
Yep. But we need to write it as two separate things because these are equations of lines. So x equals 2 or x equals negative 2.
So then your line is stuck. Like, okay. But you can't have more than one
Well,
horizontal.
yeah. Huh?
But you can't have more than one horizontal.
No.
So it can't not go down and also not go up. Okay.
It'll typically just limit it in one spot. So this will be bigger on bottom, so horizontal would be y equals 0.
I don't know what that means.
There is one other thing that I don't normally cover at this point. I usually wait till closer to the AP exam because if I cover it now, I guarantee you'll forget it by the time the AP exam rolls around. They're called slant asymptotes, which is what happens when you have no horizontal asymptote. So you can't have a slant asymptote and a horizontal asymptote. These slant asymptotes only occur when the top is one higher than the bottom. So like in this previous one, x squared over x, I would have a slant asymptote. And it's an equation of a line, like a y equals mx plus b. To find it, you have to use polynomial long division, which is why I don't cover it right now. Tyson's just like, what is polynomial long division? I don't normally cover polynomial long division. In this case, I would have to use it. A lot of times it happens in a different situation, and we can use synthetic division instead, which is easier, and pretty much all the ones on the AP exam would just require synthetic if you had to find the slant asymptote. So another reason why I wait till later in the year to cover it. That's like 2 weeks prior we discuss it because
learn that in college algebra?
What?
Synthetic division.
Yes.
Okay.
Okay.
Everything's right.
Where did I stop the other day with problems? 19.
We still going?
We're still going.
All right, continuing on your problems.
Something.
That's not much.
Is that not?
21, 23,
The same, they're the same.
37, 39,
What's the whole? She said she wanted to.
41, 49, 51, 53, 55, and
Good one.
61. Now, here's what we're going to do. Because obviously, we've been working the entire time. And I want you guys to be able to ask questions because I know there's going to be things that you have questions about. I'm going to give you tomorrow in class to do them. So you'll have all of class tomorrow to work on this stuff. And then the stuff will be due on Wednesday. Now, if we're not using our class time tomorrow to work on this, I will just move on to the next section. 1.3 notes will be due on Wednesday. And there's the 12 basic functions.
You said if we're back, they're due Wednesday?
You have a calculator?
If you're not working tomorrow, then I'm just going to start the next section is what I'm saying.
Okay, but
Now, if you've completed them, that's one thing. But if everybody's completed it, then I can just move on anyways.
so when did the next section of notes due? So
Wednesday.
Wednesday.